A couple things while you're solving that factoring to remember, things to know. So I have this 3x squared equals 2x plus 5. Like it's got all the pieces, right? It's got the x squared, it's got the 2x, it's got the 5. But what I want you to notice is it's not equal to 0. And remember, this whole thing centers on that we have to have it equal to 0. So one thing to remember, let me get this out of the way, get it equal to 0. So let's see, I can manipulate this, subtract 2x from both sides, subtract 5 from both sides. I've got 3x squared minus 2x minus 5 equals 0. Okay, now it's set, it's equal to 0. I'm going to factor this thing. So, beep, bop, boop. There's a 3x squared, there's a negative 5. I've got to multiply to negative 15x squared, and I've got to add, remember I'm adding to that middle term, negative 2x. So let's see, what multiplies to negative 15x squared adds to negative 2x? You might see it right away. I'm just going to be methodical. X and negative 15x multiplies. Nope. 3x and negative 5x multiplies. Ah, that works. That adds to negative 2x. So I can put one of them here, one of them here. Let's put that there. Let's put that there. Look across here, there's a 3x in both of those. That makes this an x, that makes this a negative 5. That makes this a positive 1. So what I've done is I've taken this area, and I've rewritten it as x plus 1 times 3x minus 5. That's equal to 0. Good. And so what that means is either this is equal to 0, so set it equal to 0, subtract 1, x equal to negative 1, or this is equal to 0. Add 5, divide by 3, 5/3. Those are my answers. Notice if I took negative 1, plugged it back into here, it would give me a 0. Plug 5/3 in, it also gives me a 0. Let's give another one here a try. This thing, well, it's not equal to 0, and I'm supposed to remember that. So get it equal to 0. So let's do that. I could subtract 27x and 6 from both sides. So I've got 15x squared minus 27x minus 6 equals 0. And I'm going to go to factor this. You know, one thing I noticed too, though, I could factor this. It's going to be pretty big numbers. But I noticed that like 6, 27, and 15, 3 goes into all of those. What I can do is I can factor out a 3. 5x squared minus 9x minus 2 equals 0. And notice 3 times whatever, I could still get to 0 as long as the whatever ends up being a 0. So I'm just going to factor this part. And really what I could think about what this 3 is saying, like if I set up this 5x squared and this negative 2, there's really saying I just have 3 of these squares. I don't need to draw them all, but really I have 3 of them, right? That's what 3 times it means. Okay, let's factor this then. Multiplies to negative 10x squared. Things that multiply to negative 9 would be, well, x and negative 10x. So x, negative 10x. So I look across here, there's a 5 in both of these. 5x and x. 1, it's got to be a negative 2. So I've got 3 times 5x plus 1 times x minus 2, right? 3 of those squares equals 0. And since these things are multiplied together, the 3 doesn't do anything to get me closer or further away from 0. Right? The 3 just sits, there's no x there. 3 is never equal to 0. So I don't have to worry about setting 3 equal to 0 and solving it. But if I set this equal to 0 and solve it, subtract 1, add 5, negative 1/5. Set this equal to 0 and solve it, that'd be add 2. There's my answers. If I plug those back in, they would give me 0. Last example like this, 9x squared minus 25. Well, it's not equal to 0. So how about we subtract 25? And I've got a middle term of 0. Hey, this is a difference of squares. This is 3x squared minus 5 squared equals 0. So if you don't see it, you can draw out the rectangle and go on your way, but I'm going to say this is 3x plus 5 times 3x minus 5 equals 0. If I set that equal to 0, that thing right there, I would subtract 5 and divide by 3. If I set this equal to 0, I would add 5 and then divide by 3. There's my answers to that.